Meteorologist Jacob Morse is here with today's Morse Code of Weather. You're starting a new series this week, I understand, about the weather warning process.
That's right. We're going to go over every aspect of how severe thunderstorm, tornado warnings are issued and the processes before those, like watches and outlooks. That's what we're going to talk about first this week. But this is going to be a multi-part deep dive series over the next several weeks on Morse Code of Weather. But first, let's see how this whole layout works. We first have to start with the Storm Prediction Center in Norman, Oklahoma. They issue outlooks that are based on a 5-category scale from level 1 to level 5 risk of seeing severe storms across the country. Then we get watches that are issued, meaning that severe weather is possible over a certain area. Then the National Weather Service offices locally, they issue the warnings over a much smaller scale area, meaning that severe weather is happening or imminent right now. And then the event actually happens. After the event, the impacts are felt with damage surveys conducted by the National Weather Service. But first, let's talk with a meteorologist at the Storm Prediction Center to see why they issued those severe weather outlooks for multiple days out into the future to give us that first warning or that first lead time that there could be severe weather.
The Storm Prediction Center is the National Weather Service severe weather experts for the whole country. We have a lot of data to look at, a lot of models, a lot of observations, but really what it comes down to here is the expertise. On any given shift, we can have 60 years of experience plus. We have lead forecasters that have been doing this for 30 years. So, you combine all that expertise, and we're doing this every day for the entire country, as you mentioned. So you get pretty good at it, especially when you're working with people that have been doing it for so long, and we're all so passionate about it. Of course, we've gotten a lot better model data, the high resolution models, as well as the ensemble forecasts that combine all the different model members. A lot of that has been developed here at SPC as well, which is really, really unique.
So those outlooks are drawn by hand at the Storm Prediction Center for the entire country on a computer based on all of that model data. And we show that on air on this 5-category scale from isolated severe storms to the highest risk of widespread severe weather. Here's the outlook for today, for tomorrow, and for the next day. So each of these are drawn multiple times per day by these meteorologists. 5
outlooks per day. And, it's especially in that day one period, it's always been like, at SPC, the day one is really kind of where we add a lot of value as far as, tweaking. So that's why we're updating it so much, because we're getting so much data and whatnot that we want to keep the information as fresh as possible. Each of those categories is really related to coverage of severe thunderstorms we're expecting, as well as the intensity of storms. So increasing coverage and intensity as you get higher in those categories. So, our main goal is to kind of give the big picture and allow for better staffing at the forecast offices. And then, when it comes down into the day one period, we issue the mesoscale discussions where we circle and we highlight areas within the larger categorical risks. And we're trying to kind of convey where we're thinking that watches might be needed, the tornado or severe thunderstorm watches, which we're in charge of doing for the entire country.
So they start with those outlooks, the broader scale, level 1 through level 5 for severe weather. Then they can pinpoint these areas, these mesoscale discussions, the areas of greatest concern where a severe thunderstorm watch could be issued. After that, the watch gets issued by the Storm Prediction Center in collaboration with National Weather Service offices, and then you get to the warning process. But let's talk about this watch process, how they work with National Weather Service offices across the country to issue those watches.
If it's looking like we're going to have a watch, we will reach out to the forecast offices affected by what we're expecting, and we'll do that internally and run a collaboration call. So that will be done by the lead forecaster on shift here, and he will talk to all the forecasters at the local offices and just kind of iron out the details of the watch, tornado, severe thunderstorm, which counties should be involved, how long should the watch be going for. So yeah, that's a very collaborative product. In the end, we make the final call here at SPC. It's definitely a balancing act as far as watch size. Like you said, being in a watch, and if you're in too many and you Yeah, we're always in a watch and we never see any weather. That's obviously not ideal, but again, I think a lot of it is communicating to the public what the watch actually is. The watch is it's a watch. It's that saying that the conditions are favorable in and near the watch area for severe weather. We're not necessarily saying it's going to happen at any given location. That's much more into the warning scales. We do have the ability to upgrade a severe thunderstorm watch to a tornado watch. So there are a little bit more rare, but you could end up starting in a severe thunderstorm watch, and then a piece of your area could be upgraded to tornado.
So the ideal process is you have the watch issued first for a broader area, and then you fine scale where the storms are developing that are the strongest and issue those severe thunderstorm warnings or tornado warnings. But it doesn't always happen that way.
Not every warning is going to be expected to be in a watch. We're looking for more concentrated corridors of severe weather. Yeah, there's a little bit of nuance, there's some human factor, but in general, we try to be very consistent, and we do verify our watches, on a gridded, coverage scale and everything. So we'll look back and say, oh, that maybe should have been in a watch. There was a little more reports than we were expecting, or that was a little bit, not as many reports as we were expecting.
So there's a lot that the talented meteorologists at the Storm Prediction Center in Norman, Oklahoma are responsible for. Those large-scale convective outlooks for multiple days in the future for the whole country, then those mesoscale discussions, honing in where severe weather is possible, and then issuing those watches that are a collaborative effort with local National Weather Service offices.
And the Weather Service offices and the Storm Prediction Center, they do their best to issue the watches when necessary, but one thing people may not know, they're kind of graded on their watches and warnings when they're issued so that they're just not put out for no reason.
Right, there is a verification process, and it's all about the size of the watch, the time scale that they're issued at. It's always a learning process with meteorologists.
It always is.
Good stuff. Thank you, Jacob.
You're welcome.
It's Morse Code time, picking up where we left off last week. The meteorologist Jacob Morse is here to give us the inside scoop on the National Weather Service.
Yeah, so last week we talked about the Storm Prediction Center, and they're located in Norman, Oklahoma. They issue the severe thunderstorm watches as well as the convective outlooks for several days into the future, forecasting where in the country might see severe storms. Now we're going to take it to the local level. Each county has assigned to a National Weather Service office. It's divvied up across the country based on geography. The Weather Service office responsible for 36 counties in western and central North Dakota is located in Bismarck near the airport. So that Weather Service office needs to have staffing for quiet weather days. And normally there's just two people, or two meteorologists there, a forecaster and someone that's worried about social media and taking official observations. But when there's severe weather that's forecasted or a severe weather event that's taking place, it gets a lot more crowded in the National Weather Service office in Bismarck. They can have as many as 8 to 11 meteorologists with a variety of different roles. And I'm going to send it over to Zachary Hargrove at the Weather Service to explain all the different responsibilities of these roles.
On a quiet weather day, we usually just have two people working here. We have one person doing the forecast and one person monitoring social media, taking observations, looking at all the data, making sure that's good. Then it gets quite a bit different when we have severe weather. It gets a lot more exciting. This place is a lot more full. So let's just talk about a really busy severe weather day. We can have upwards of, say, 8 to 11 meteorologists here on the floor. We'll have an event coordinator who's kind of making sure everybody's doing okay, everybody's not too tired, and just kind of keeping an eye on the big picture. We'll have 2 to 3 radar teams depending on how big the event is, how widespread it is. So a radar team consists of 2 people. You'll usually have one person drawing the polygons, really analyzing the rotation if we're looking at a tornado threat, and just looking at a number of different things for hail and wind. And then we'll have another person who's looking maybe more in depth at some of the dual polarization data, some of the more advanced data, some more of the mesoanalysis and environmental aspects. A lot of times we'll have a mesoanalyst too, a dedicated mesoanalyst, who will be keeping those other radar team members up to date with some of the environmental parameters to say, hey, you need to focus on the tornado threat, hey, you need to focus on the giant hail threat. So that is really helpful to the radar operators. A lot of times we'll have a person monitoring social media. We'll have somebody who's in charge of communication. So that person will make sure if we get, say, a tornado report, that the appropriate people know, that the radar operators will know, and they can forward phone calls to them so they can actually look at what look at the radar or what the person's reporting.
One of the roles that Zachary mentioned was the mesoanalyst. Let's expand on that a little bit. That's looking at the environment, seeing if there's enough instability for severe storms to fire up. That's called CAPE. And there's a bunch of different model viewers that the meteorologists look at to see exactly where that instability might be maximized, where there might be the most shear in the atmosphere that might lead to more of a tornado threat or more of a hail threat. And there's a bunch of different composite indices, too, that these mesoanalysts have to look at, and then those are communicated to the radar teams so that they have the best information possible for issuing those warnings. Now let's focus on the social media aspect and how that's changed over time.
Social media has become a much bigger form of communication for us over the last, I'd say 5 to 7 years. I know that when I first got here, it was a thing, but we weren't really strategizing on how to having one person dedicated to answering questions or posting, and now we kind of have that streamlined to where we have a method, we have somebody dedicated to that, where maybe when I got here we didn't always have that.
So the meteorologists need to be ready to come into the office when severe weather strikes. Zachary is now going to talk about how much of a lead time and how they prepare for getting more people into the office.
A lot of times we'll notice these bigger events coming, 2 or 3 days in advance, and we'll start getting an idea. We'll start looking at the schedule, who might be available to come in, who is actually working, who's certified to work radar, all those kind of aspects. But a lot of times when we actually make the decision to get the extra people in will be when SPC, the Storm Prediction Center, is contemplating some kind of severe watch, whether that's severe thunderstorm or tornado watch. When we get the impression that that's coming, we'll start planning and getting some people in.
So that's the ideal scenario, when you have some lead time, knowing that a severe weather outbreak is going to be coming a couple days in advance. And then when those watches gets issued, they can bring in a lot more people to the office. But what happens when you can get a couple of severe thunderstorms that pop up somewhat unexpectedly?
The first priority is getting any kind of alert or warning out if it's needed. That's our first priority. A lot of times, depending on how widespread the event is, then we'll start calling some people in. Once the products are out, once we feel like everything's warned, the public is aware, then we'll go ahead and try to get a couple extra people in. Usually we can get people here within 15 to 30 minutes.
So there's a lot of different roles that the meteorologists have during a severe weather event at the National Weather Service, a lot of teamwork and communication. But what's Zachary's favorite role to have during a severe weather event?
I like working radar. That's kind of my thing. I love working severe convection, and so I like working radar. But over the past few years, I've really gotten to where I like doing the event coordinating too, because I enjoy the kind of the overview and seeing all the moving parts working together, and it just gets me moving around the operations floor. So I really enjoy that as well.
So it's kind of cool being able to go behind the scenes there, see the inner workings of the National Weather Service. So we have the end product of getting the warnings on our phones and on TV, but there's a lot that goes into it, a lot of people behind the scenes working together collaboratively to get the proper information out to the public. And they have high resolution radar data straight from the radar there on site, coming in with up-to-the-minute scans to disseminate those warnings.
Looking at all those different responsibilities, two meteorologists here, what would you pick in a severe weather situation? What would you want to be doing?
Well, Zach already got the good one. It's the radar.
The radar, that's the best
that's
one,
where
huh?
it's at. Yeah, and I also like how, Jacob, how you mentioned how the Storm Prediction Center puts out their advisories and then it's broken down to a more local level. That's kind of what happened yesterday, because Storm Prediction Center kind of had Bismarck including the area, but the National Weather Service office in Bismarck had their data and did not include them because there was little to no severe weather threat for Burley.
Yeah, so it's even collaborative from the national level at the Storm Prediction Center down to the office here in Bismarck.
Good stuff. Thank you, Jacob.
You're welcome.
There's a chance the Weather Service could be issuing a severe thunderstorm warning. If they do, there's a polygon that they issue around the storm to give you an idea, a storm-based warning, right?
You're going to explain.
You're not. Jacob's going to talk all about it, believe it or not.
Yeah.
What a good segue, right, Jacob?
Yeah, so how are these warnings warnings drawn by the Weather Service. We're going to continue our severe weather warning process series on Morse Code of Weather here. Last week we talked about how the Weather Service prepares for these severe weather events, getting more staff into the office, but now we're going to actually go through how they draw the warnings. And what classifies a severe thunderstorm warning? It has to be 58-mile-per-hour winds or greater, or 1-inch diameter hail or larger. Combination of these two can also be the same. And then a tornado warning would be if there's a tornado that is radar indicated or confirmed by a spotter. So we're going to go through the process with Michael Holland, a meteorologist at the Weather Service, looking at a simulation, training module, if you will, of how they issue these warnings step by step.
The first thing we have to do is we have this little indicator here that says drag me to storm. It can be either a point or a line. So I'm going to issue a severe thunderstorm warning for this section of the line right here. So I'm going to change it to track a line of storms. I'm going to match these points up with the line here. And then we're going to kind of get a motion to the line. So kind of go back in time a little bit, drag the line back to where it is, so we can kind of get get a storm track, if you will. And then I'll re-hit. So you see the first time that I moved this, it came up with this first guess box. So now that I have that line tracked, I'm going to hit track again. And I think I need to go to the current time there. This is the box, so it gives us a first guess box. So we don't really, have to draw that, but we can edit the box, and we often do. One thing we want to make sure is that if we're issuing this warning, especially if there's a warning about to expire, we want to make sure that we capture the ongoing threat. Other things that we need to consider are expected storm motion. Now, we see here the way I've tracked it, it's kind of, maybe it has a little bit of a southeastward component to it, but if I'm looking at this, if I go back and forth, the northern edge seems to be maybe a little bit more due easterly. So I'm going to kind of, maybe extend the edges of the warning a little bit to kind of account for that potential uncertainty. We do still concern ourselves a little bit with county boundaries. It's a storm-based warning. It's not, we don't warn a whole county at a time. But we also want to make sure that, we don't maybe leave out slivers of counties, so we don't have to, do things like we don't have to warn people twice, so to say. Other geographic considerations sometimes go into it, like in this example, where I've clipped the northern part of Bismarck, and if I'm really confident that the worst part of the storm is going to get to Bismarck in about a half hour, 45 minutes, in that case, I might want to include the whole city of Bismarck. If I'm a little less confident, maybe I take it just a little bit north of Bismarck. And again, it's kind of, we don't want to be, too centered on where the high population areas are, because everyone deserves a warning, no matter where they live.
So now we have our polygon drawn that will become a yellow outlined polygon for a severe thunderstorm warning. There's a couple more options that Michael needs to choose before he sends out that warning.
Here we have our polygon, and so we have a list of things to go through to check. So the first one is what's our reasoning for the warning? Do we have reports, or is it because we're seeing something severe on radar? So in this case, I'll just leave it as a Doppler radar indicated. Here we choose, the next part is to choose your wind and your hail thresholds. So this is a really strong line of storms with some high-end winds. So I'm actually going to go all the way up to 90 miles per hour, which is, we did have some measured wind gusts of that high in this event. Then you choose your hail size. In this case, with a line of storms, we're usually less concerned about hail. So maybe I'll choose a sub-severe hail size, nickel size in this case.
Now, based on the severity of the severe thunderstorm warning, it gets assigned into one of three categories. A base level severe thunderstorm warning is just for 58-mile-per-hour winds or 1-inch hail. A considerable tag on that warning means there's 70-mile-per-hour plus winds or golf ball sized hail. And the highest level severe thunderstorm warning, destructive 80-plus mile-per-hour winds and baseball sized hail. And for that severe thunderstorm warning, you'll actually get a WIA alert, emergency alert sent to your phone, similar to what you would get for a tornado warning.
One thing that we'll actually do now that the high-end severe thunderstorm warnings get activated on people's phones. So we might have a large warning like this. Maybe we'll only go 70 miles per hour for the large warning. If there's only a smaller area within that where we're really confident that there's going to be really intense winds, We can issue a smaller warning embedded in that would be for the 80 mile per hour plus winds.
So now the polygon is drawn, we have some of the options selected, we get this big text paragraph spit out with the hazard, the source, the impact, the locations. How long does this whole process take before that warning gets issued and disseminated to the public?
We like to keep it, I would say at the very least under 2 minutes. Under 1 minute, even better. We want to be as efficient as we can, but we also want to be accurate. So I think a lot of it, we have this room where we kind of practice issuing warnings, and a lot of that is just making sure that we're familiar with our options here, so that when I pull this up, I get my, my storm track right and the box right, I can just go through and, quickly pick, okay, 90 mile per hour winds, nickel-sized hail, tornado possible, this call to action statement. So we can go through it really fast.
So there's a lot of high resolution radar data that's coming in, not only just reflectivity, but also the velocity data, how fast those particles, those raindrops are moving in the atmosphere. But there's other things that the meteorologists, the Weather Service need to consider to issue a tornado, or in this case, a severe thunderstorm warning.
We're always keeping in mind, does the environment support what we're seeing on radar? If the radar data is telling us there's a severe storm and the environment is favorable for severe weather, then that usually keys us in to, yes, this is going to be a severe storm. We kind of tend to this 2 out of 3 rule. So we have the radar, the environment, and then reports. So if we have 2 out of those 3, then that really increases our confidence that we're dealing with severe weather. If only one of those is true, then that's that's more cause for evaluation and more careful consideration to whether or not it's something that we need to warn the public of.
So a lot of quick decisions that these meteorologists need to make when drawing and issuing those polygons, but respect the polygon. If you're in that severe thunderstorm or tornado warning, seek shelter immediately.
Time is of the essence, right? And Monica loves it when I call her at 2 in the morning. It's Weather Call that actually calls with my voice on it. So when you hear from me,
Well, you got to respect the polygon.
you better respect the polygon. Check it out at yournewsleader.com. It's called Weather Call, and every time Michael or one of those guys, the Weather Service, they're the official agency that issues the warnings. Every time they issue a warning and you're in the confines of the warning, your phone rings and you are notified within seconds.
That's right.
Check it out.
It always gets me out of bed. I'll say that.
Me too. Yeah. Thanks a lot, Jacob.
You're welcome.
Talking about Weather Service tornadoes, how they issue them, and all that, timely with what just happened yesterday.
Yeah, we did have that one tornado warning that the National Weather Service drew and issued in northwest Burleigh County near Wilton and Regan, and we'll see if that actually produced a tornado after we go through some of those damage assessments. But North Dakota sees about 30 tornadoes per year, with the peaks being in June and July. And when Weather Service meteorologists are examining radar data to issue a tornado warning, velocity data is one of the really important products that allows us to see inside of storms, sees where that rotation could be to identify where that potential tornado might be.
For a tornado warning, we're going to want to be going kind of back and forth between the reflectivity and the velocity. In this case, we had some data issues with the velocity. You can kind of see here the jagged edge between the red and the green, so I'm more going to stick to reflectivity. And let's say that we're concerned about this hook area right here for a tornado. So I'll drag that there. I'll make sure that I have tornado selected. And we usually only issue tornado warnings for about 30 minutes or so. So I've dragged my point there. I'm going to go back in time for a few minutes so I can get a good track on this feature. So again, it looks like it's kind of moving maybe to the southeast a little bit. So I get my storm motion. Then I hit the track button again, so that gives me my first guess polygon. If we think our possible tornado might be right there, I'm going to kind of make it small in the beginning, but I'm going to fan it out so that we can get a much larger area. So on the bottom here, I'm kind of trying to line up this side of our polygon with the way the storm's tracking. And the reason why I would want to make it this big on this side is that sometimes what we see with tornadoes is that they kind of occlude back left into the storm. So it's accounting for uncertainty in the storm motion. I don't know. I think we're getting close kind of into Mandan here, so I don't know this far away if we would necessarily put them in the warning yet, depending on our confidence level and on the environment. If our environment's favorable for long track tornadoes, then we probably would. So maybe I'll add another point here so that we can maybe kind of make the box look a little bit more like that. So we still account for that uncertainty coming down here to our south and east, but not quite have it go quite as far into where this radar is. So that's right here at the Bismarck Airport. So if you can imagine, Mandan would be kind of right around there. So again, kind of keeping geography in mind, but we don't want to spend like minutes, agonizing over that decision. We just have to kind of make a quick first decision and just go with it. Science has come a very long ways, but we still can't predict with 100% accuracy there's going to be a tornado here. It's going to move like this in a half hour. So it's really a balance of making sure that we give people that are in the threat area enough of a lead time and account for uncertainty in storm motion and storm evolution, but at the same time not overwarning people. It's a number of factors that we consider, but the most important thing is that we get this out in time to give the people that are in immediate danger as much of a heads up as we can.
So as Michael's going through that simulation or training module, you can see that they have a lot of decisions they have to make really quickly. They want to get that polygon drawn in ideally less than a minute. But once they have the polygon drawn, Michael has to choose a couple more options before the warning is sent out.
So we can start with this base tornado warning. This is usually what we'll start at if it's just if we're seeing signs in the radar data and we have a favorable environment for tornadoes, but we don't yet have confirmation of one. A considerable tornado tag, that would usually be used if you have confirmation that there's a tornado on the ground. The tornado emergency, I don't believe that our office has ever issued one. That would only be that'd be a very rare case where if we had confirmation that there was a large and destructive tornado on the ground heading towards a population center.
So those different tags are important to select, but a tornado warning polygon can also be updated on the fly as that storm is moving towards and into that warning area.
And we started with Doppler radar indicator. Let's say in 10 minutes we get a confirmed report of a tornado. We would update this warning. We can take out where the threat has already passed. So if it's here in 10 minutes, we'll take out this back portion of the warning. They're not under a threat anymore. We'll change it to say that now a tornado has been confirmed. What we can't do, unfortunately, is we can't expand the current warning, if you will. We would have to issue a new warning. So if this was going to continue to track towards, I think the Missouri River's right here, if it was going to get into Burleigh County, we'd have to issue a new warning for that. The way it's set up right now. So we can reduce the area, but we can't expand it. We also can't extend the time of the warning as well. That also requires the issuance of a new warning.
So before the warning is sent out to the public, they get this big long text statement that's spit out. That's also distributed to the public and is shown on your apps and on TV. And it indicates the hazard, the source, the impacts. And these impacts are depending on how strong the tornado is, where it's going to be heading. But there's certain safety precautions that you need to be aware of if a tornado warning is issued for your location. You need to have multiple ways to receive warnings, especially for tornadoes. We're going to be talking about them on TV and on our First Warm Weather app. If one is issued for our area, you can get our weather call service. You can find out more about that on our website. Your phone should have a built-in WEA service, wireless emergency alert, kind of like with Amber Alerts. You should get a tornado warning alert on your phone if you're within that polygon. Having a NOAA weather radio is also really valuable in case your power goes out, because this thing will always be on. And if you're outdoors and in a larger population center nearby a tornado siren, that can also be useful to be notified if a tornado is coming your way. But if you are under a tornado warning, put as many walls between you and the outside as possible. You would ideally want to get down to your basement or an interior room, because tornadoes can cause a lot of damage, especially if you're in a mobile home. Manufactured homes are not a safe place to be during a tornado warning, so make plans ahead of time to try to go somewhere else to a more sturdy structure. If you're on the road too, it's a misconception that going under underpasses is a good idea. That is not a good idea. You would want to get off at the closest exit, go to a business or a building that's a much sturdier structure if you're stuck on the road in a tornado warning. Now, the Weather Service has a certain statistics that they use to improve their tornado warning process. The false alarm ratio for the Weather Service office in Bismarck that covers western and central North Dakota is 63%. That means that a warning is issued for an expected hazard, such as a tornado, but that hazard never materializes. The other statistic is the probability of detection. That's 56% for the NWS in Bismarck. That means a higher number, a higher percentage, means that they're correctly detecting and issuing warnings for tornadoes before they touch down. And these numbers are actually a lot better than some other Weather Service offices across the country, and it's a learning process that these meteorologists need to use in order to get better at issuing these tornado warnings.
And those values are actually on par or slightly improved above regional and national standards. There's been a lot of research that's been devoted to tornado genesis and how we can better anticipate the threat of tornadoes. There's a lot of research that's been put into that over the recent years, and we're continuing to learn new things all the time about how we can better anticipate so we can improve those statistics.
So there's a lot of split-second decisions that they need to make when they're drawing those polygons, but if you're in the polygon, in that tornado warning, seek shelter immediately and take it seriously.
Respect the polygon, right?
no
Talked
kidding.
about that. So we had a lot of polygons yesterday, keeping you informed of the severe weather. Weather Service, hats off to them because they're the official agency that issues all of this, and we just pass it on, right? We're meteorologists that interpret the data, but a lot goes on behind the scenes. That's the bottom line.
Exactly.
Yeah.
All right,
Thanks
thanks
a lot.
you guys. Meteorologist Jacob Morse is here. You're continuing your series on severe weather warnings. What do you got today?
So we talked about how they, National Weather Service, meteorologists also issue watches, warnings to get the message out about incoming severe weather. But what happens after that severe weather strikes? Well, the National Weather Service meteorologists need to go out on damage surveys in order to assess the damage and determine if it was a high-end wind event or a tornado that caused the damage. So they get tipped off that there was damage at a certain location from emergency management, from law enforcement, from the public. Sometimes we relay information to the Weather Service that there was damage at a certain location. They'll drive to that point and interview people at the scene to see what happened. Here's JP Martin going over some of the specifics with damage surveys.
The first thing we have to determine is how intense the storm was, what type of damage was done, were there any injuries or deaths. Now, if there were any deaths or injuries, we're going to go out and damage survey to determine, was it wind, high wind that did the damage, or was it a tornado? That's what's very important, is to get out there as soon as we can before anything is disturbed, right? We want the evidence to be what it was before anybody moved anything to help us determine, was it wind that did the damage or was it a tornado? It's a challenge, right? Because I'm trying to talk to you about your experience during this event that has now turned your life upside down. Maybe no one was injured or no one was killed, but your home is severely damaged, or your farm, your property. And here I am trying to talk with you about your experience. So it can be a big challenge to do that. It's why we now want to take two people. We want to have a team approach to this so that I could be talking to a person and not stopping to write notes down, but have someone with me to take those notes for me.
So not only has the team approach changed with how they conduct those damage surveys, but also the technology and the materials that they bring along with them on the damage surveys.
We still take a bucket with us with all these things in there. We still do that just in case, because we want to write notes down. We may need to look at a map or something like that because parts of North Dakota, internet access is lacking and we're not able to use the software that we have on an iPad. But today we take an iPad with us and use that software on there, a program that accounts for all these things you see here on the table.
So that technology allows them to plot the GPS coordinates exactly where the damage occurred. At each one of those points where damage occurred, they'll assess based on a damage indicator. There's a list of 28 damage indicators ranging from trees to buildings to schoolhouses to outbuildings, farm buildings, etc. A whole list here of different things that they can assess and determine how severely it was damaged. That's called the degree of damage. All of this is then used to assess how strong or severe that tornado or high-end wind event was.
So we have all these different damage indicators, and then once we find our damage indicator, a pole, a light pole, a tree, Was it a softwood tree or a hardwood tree? Once we determine that damage indicator, then we look for, well, how badly was this thing damaged? And that's what takes us up on the scale. We have 28 damage indicators to look at, and it has not expanded since it began in about 2007. But we, the National Weather Service office in Bismarck, we're pushing for more damage indicators, especially on farms. You know, farm equipment, a pivotal irrigation system, things like that are not included. So then when something happens to that pivotal irrigation system, it's not one of our damage indicators that we can really assess.
Again, they're looking for a pattern of damage to assess, was it straight line winds or was it a tornado that caused the damage? With tornadoes, you usually see a bit more of a circular pattern with the damage versus with a high-end wind event. All the debris is usually pushed towards one direction or at least in a divergent pattern. And again, they're using the debris and the damage to assess the severity of the storm after the event happens. And with tornadoes, it's put on an EF rating, the Enhanced Fujita scale, from 0 with 65 to 85 mile per hour winds to the strongest tornado, EF5, with 200 plus mile per hour winds. And the damage, of course, increases in severity as you go up the EF scale.
So we have to be careful when we assume, oh, this had to be a tornado. We hear that a lot. When I go to a damage survey, when I go to survey the damage, in my mind is not that this was a tornado and I want to disprove that. In my mind is this was not a tornado, and now I need the evidence to change my mind to say it was. What we do for tornadoes, we look for circular patterns through a field, through a tree row. We look for debris, things that were destroyed by the event. We look for debris back the way the event came from, because wind will not blow stuff a half a mile back, right? But a tornado will.
Some notable surveys that JP mentioned that he's done throughout his career was in 2009, the 789 tornado, which was an EF3 strength in Dickinson. And then in 2018, there was an EF2 tornado that struck Watford City. Now, over the past couple of years, the Weather Service in Bismarck hasn't done many damage surveys in western or central North Dakota. This year, however, they've gone on a couple. One was just at the beginning of the month, August 1st, in the Beulah Bay, Hazen Bay area, where they determined, based on going to that site, talking with eyewitnesses, and seeing how the damage was strewn out in kind of a divergent pattern, that was wind damage between 80 and 95 miles per hour. And also on August 1st in Wilton, there was an EF unknown tornado that was surveyed by the Weather Service, meaning it didn't strike any structures or there weren't any damage indicators that the tornado impacted, so therefore they can't assess the rating of the tornado. It was likely a brief and weak tornado, however. So we'll talk about all those different damage indicators and what the Weather Service has done over the years here with JP.
In that case, it was wind, but we used the damage indicator from a tornado and wind speeds associated with that. We use that to then determine, even if it was not a tornado, to determine, well, how high was the wind associated with this event. Then we look at just how badly was it damaged? Well, it was completely destroyed. Was it strapped down or not? Those things would add to, well, was it 115 miles an hour, 120, 130? What was it in that EF2 range? And we decided about the middle of the road for that home. About 125 miles an hour was an appropriate number to put on. In this case, we determined that it was divergent, oriented toward the east-southeast, and so again, that led to our determination that this was wind damage and not a tornado. Had the debris been converging, coming together downstream, we would have probably had a different determination that this would have been a tornado.
So JP and the video there was referring to the Sioux County high-end wind event that happened in June of this year. So what happens if you encounter or are dealing with severe thunderstorm or tornado damage? What should you do?
Immediately, you should notify their county emergency manager or tribal emergency manager and let them know about the damage they have. And then say, hey, by the way, can you call the National Weather Service? Because a lot of things happen that we're unaware of. You know, we suspect there had to be damage from this thunderstorm, and yet we don't hear about it. And who do we call, you know, to try and find out? Well, we call an emergency manager. Sometimes they don't know about it either.
And sometimes you need to be patient with the Weather Service because it can take a couple of days for them to go out and assess damage, especially if severe thunderstorms struck multiple locations. But it's a process that involves engineering knowledge as well as meteorological knowledge to get that rating for a tornado or the severity for wind speeds.
Wow, okay. Well, to understand severe weather, meteorologists like my friends Henry and Jacob here need to do some research. Jacob Morse is here for more on this in today's Morse Code of Weather.
We're going to be talking about home construction research this time in order to protect our homes and structures from severe weather. So in our severe weather series, we've talked about the warning process, how you can get those warnings when severe weather is going to strike your area. But even before that, preparing your home or your business, any buildings, for the forces of Mother Nature that she can bring with severe storms is really important. And there's a unique test facility, research center in South Carolina called the Insurance Institute for Business and Home Safety. And they do a lot of different really interesting tests. We'll send it over to a meteorologist there to explain an overview of IBHS.
So here at IBHS, we are a unique research facility that is able to import full-scale structures into our test chamber and see how weather and wildfire impact the built environment. In our test chamber, we can test wind, wind-driven rain, hail. We make our own hail here at the lab, and we can shoot that at cannons at a structure. We can also do that in our small hail lab as well and test things like shingles or other roofing materials. Also siding materials, we're also checking those out as well. So a unique array of research that we use here over our more than a decade of research has really been used to inform the insurance industry, industries across the enterprise of weather, construction, engineering, all of those industries working together to ultimately make homes and businesses safer for people going forward.
So at that test facility, they have 105 fans or turbines that can produce 120 plus mile-per-hour winds, and they import these full-scale structures into that chamber that they build on site. So the severe thunderstorms can pose a whole bunch of different hazards to our homes and buildings. They can bring high winds, they can bring hail, and a lot of these are being tested by the meteorologist at IBHS.
Understanding risk for a homeowner or a business owner, that's so important when we're talking about the perils of Mother Nature. For thunderstorms, they bring wind-driven rain, and hail, all things that we research here. So understanding the mitigations that can help protect you and your family from damage, that's really what we want to look at. In regards to thunderstorms, they can produce damaging winds. We've identified one of the most vulnerable openings in your home is the garage door. It's the largest opening, so if that fails, what happens is if that is not a wind-rated garage door, which unfortunately most are not that are currently installed in the U.S., those doors can fail. And when they fail, the wind can get into the home, pushing out on the walls and pushing up on your roof. That then allows those forces inside your home to work with the wind on the outside. It's actually trying to pull the walls out and pull the roof up. So when the wind gets in, it just adds to that. And when that happens, you can have more significant structural failures, things like partial roof deck loss, or potentially all of your roof could be torn off. We have seen that here in our facility. It's going to find that weakest point in, and then it's also going to find the next weakest point out. And once you've lost your roof, then the rest of the home is much more at risk to damage, as the walls now don't really have that support. In the way of hail, hail can really make an impact, so to speak, right? That can dent our shingles, tear them, that can reduce the performance, that can allow water to get into our attics there and cause costly water claims as well. A sealed roof deck is critical because when your roof cover potentially is blown off by strong winds, those seams there, those can let water into the home. So that sealed roof deck is going to provide some sort of a tape that's going to fit over those seams, or potentially a peel and stick underlayment. That's another option. But what we want to do with that is keep the water out so that potentially a roof claim doesn't become an additional costly claim there as you're having to consider water. And so it's all about understanding the performance of various materials under the conditions that we can simulate, and helps us to better understand what we really can expect. Is there such a thing as a 20, 30-year warranty on my asphalt shingle roof? These are the critical questions that we can answer here at our facility.
So all these different research tests that they do really inform the construction industry when they're building new homes, and inform the officials that create building codes so that our homes can be safer in the future.
Many people might be surprised to hear that not every state in the United States has a mandated statewide building code. North Dakota is a state that does have a statewide code. Unfortunately, it is not well enforced, and so code adoption is important, And code enforcement is even more so important, right? Because if you have a great code in place, but you're not enforcing it properly, then we're really not maximizing the benefits of that. So we are very focused on supporting modern building code adoption across the U.S. so that more families can have access to safer structures. And our Fortified program is one great way to do that. That offers you a retrofit option in the way of fortified roof and installing those opening protections, like installing a wind-rated garage door, potentially impact-rated windows, and that kind of thing. So that's a great way to retrofit your home and trying to protect your home, even if your local codes might not be to the level that you would want them to be.
So a lot of groundbreaking research at IBHS to inform the general public and those elected officials that are making decisions about our building codes. But as homeowners, what is the message that IBHS wants you to take home?
Well, we are very focused on consumer education, education for insurers, education for builders, engineers. All of these organizations and groups, officials, we all work together to try and make our communities more resilient. And so making people aware that there are things that you can do to protect your home. You don't have to rely on somebody else to make a decision for you about your building code for the next generation of homes that are going to be built. Building codes are great, but unless you're building a new home, it's going to take some time to be able to make a meaningful difference and potentially a generation of homes and businesses being constructed to those new codes before that has really seen the benefits. That's why retrofits are very important, because that can give you the best chance now. But education and awareness as to what's available and what's possible are so important, and also letting people know that it doesn't have to be a concrete fortress to be able to withstand the forces of Mother Nature. There are accessible resources that you have.
So a lot of unique research being done in South Carolina there at the IBHS facility. You can find out more information at ibhs.org. But it's one of those things you don't think of until the severe storm strikes your home and you could lose everything. So making sure that it's safe and fortified from those strong winds, from the hail that can do a lot of damage to your roof is really important ahead of the storm.
Yeah, good stuff. Thanks, Jacob.
You're welcome. During my severe weather series, we've talked about how National Weather Service meteorologists draw tornado warning polygons. But what's the future of these tornado warnings? They're one of the most important things that the National Weather Service does to alert the public of a very serious impending threat. Now, these tornado warning polygons, it's either you're in or you're out of the polygon, and you have about 10 minutes to seek shelter. That's the average tornado warning lead time that you get. And not everyone in this polygon is going to see a tornado. There's a lot of space in here where people get overwarned for a threat that never really materializes. So what's the advances that is being done with research at the National Severe Storms Laboratory? Well, they're using advanced computer models to use probabilities to predict these individual strong supercell thunderstorms and increase the lead time that people have to seek shelter. I'm going to be talking with a person at the National Severe Storms Laboratory as well as a meteorologist at the National Weather Service in Bismarck to see what all of this research means in our future.
So this war on forecast system, it's a long-term development, but we're in a really exciting phase of it now. So we started back in 2009 with this vision to build an ensemble that makes probabilistic predictions of individual thunderstorms. And it took close to a decade to build that system and start testing it in real world kinds of scenarios. And it's doing really well in our experimental runs. Instead of issuing severe storm messages at moments in time, like we do when the Weather Service issues a watch or a warning, that we want to update that information all the way along the timeline between watches and warnings. And that every time we get new radar information, satellites and new weather models, they're coming in every minute or every 5 minutes, we can update not just the scenario that's unfolding, but the odds of a specific storm at the city level. Is it going to produce a tornado versus a damaging wind report? We'll have that kind of information. So there are some other weather models that take in radar data about every hour, but the War on Forecast system reads in not only radar, but also satellite information and other observations every 15 minutes. So it's about 4 times as rapid in keeping up with how the severe storms look right now. And that helps it make better predictions out a few hours. When it comes to these individual storms that may produce a damaging event 2 or 3 hours from now, it's very difficult to issue a specific warning on that the way we do it right now based on radar alone. So having WAFs will give forecasters these probabilities, the chance that that storm might hit, a sporting event or a concert that's happening outdoors a couple of hours from now, even places like hospitals where there are a lot of vulnerable people who need to move to shelter. And so, even if there isn't an official warning on that storm, if a knowledgeable user can see that there's, hey, a 20-30% chance that this could happen, they might choose to take shelter anyway. I really think that there will still be watches and warnings. It's this proven way that we do business that has worked for decades. But we want to add to that the probabilistic information. And you all are familiar with this in terms of the chance of rain today. It's kind of the same thing. What is the chance that this specific storm is going to come near me and be hazardous? So however you receive weather information, that's probably not going to change, but what you hear might become more detailed, and you can make better use of that.
One of the major goals of this project over the next decade is to extend the lead time for areas outside of the current warning, where we know in the next little bit there is a very high likelihood of a tornado, to really giving folks that maybe need 1, 2, 3 hours to really prepare for severe weather on a fine scale. That we need to be highly confident, say, before we evacuate a campground or move a large facility into shelter, right? They need to have a certain level of confidence, but at a longer lead time. That's what this research is really destined for. And I also want to emphasize that even with the advent of machine learning that'll be applied to this, that really just helps forecasters, meteorologists sift through massive amounts of data, gives them better first guesses, if you will, and they're always going to be applying their expert knowledge to help really identify where those alerts are going to go out. So it gives them a much better first guess in 5 or 10 years as we evolve and apply this research to it. But you're always still going to get an alert. It might be in a different form or multiple formats that help you make decision making better. But there's still going to be meteorologists, experts in your local area behind those warnings and those alerts, no matter what format they end up taking.
Technology has changed so much in just the past couple of years, and it continues to exponentially change, and it gets only better in the future, and that long lead time for warnings.
You have more information than you can actually deal with.
That's
in
true.
a given moment.
Time is just time, right? But the data is all, it's expanding, so it's a good thing.
All right, it is.